Hi, this video is all about reverse engineering the LEDs on one of these little beasties, which is a BBC microbit. The beauty of the microbit is that as soon as you turn it on, you get instant gratification. You get something that works. Doesn't come out very well on the camera, but that's supposed to be a smiley face. Turn it off and it goes away, turn it on and it comes back again. There's lots of stuff on the internet about programming these little beasts, but I can't find very much about the actual hardware, or how in fact the LEDs are wired. There's a little bit of a clue if we look at the edge connector pinout. So what we have along the bottom is this edge connector. Interestingly, the connections are only to the front of the board. Although they're gold plated, or appear to be gold plated, the ones at the back aren't actually connected. So what do these connections do? Well, they bring out the input-output lines of the microcontroller. So if we have a close-up look, it tells us that some of the LED columns are brought out to the side. I'm informed that these can be used as general input-outputs, but only if we don't use the LEDs at the same time. So what we've got here is column 1, column 2, column 3, column 4, 5 and 6 don't appear to be brought out, but we do have 7, 8 and 9. So then it appears that we must have sort of 9 columns, and if we want 25 then we'll have to have less than 27, which 3 lines would give us. So probably we're going to have 3 rows and not use 2 of the LEDs on the 3 rows to give us the 25 LEDs. If we look at the board, what we can see is that the tracks are visible underneath the lacquer that's on the top to protect the board. But these tracks are very complicated, difficult to follow. They seem to go through to the other side quite often, and I couldn't actually work out where they were all going. So what I did was to have a look at the processor itself on the back, the microcontroller or processor, and when I had a look at that, what I saw was there's 5 resistors out to the right hand side, 4 resistors below. There's also a capacitor, well, I believe it's a capacitor here that connects to the positive and negative, which are on the corner. So what I wanted to do was to have a look and see what I could do to find out how to reverse engineer it. So one of the first things to do was to look at the resistors on the back. So if I take a multimeter, put it on ohms, and then have a look at the resistors, see if I can actually get the probes onto the resistors, because these are surface mounted and quite difficult to get to. But if I put them on, I don't know, can you see the meter? There we've got the meter, there we've got the resistors. Just put a probe on each side of the resistor, and hey presto, 120 ohms. Try a different one. Yep, 120 ohms. So it seems like these resistors are the right sort of size to use to reduce the current to the LEDs. So maybe these then are the resistors. The next thing I needed to do was to find out what's connected to what. So to do that, we put our meter on continuity, or at least on this one on the minimum ohms, and try to find out if anything connects to anything. So if I try, for example, the bottom of these 2 LEDs, nothing. the bottom of these two LEDs, still nothing, and the bottom of these two LEDs, still nothing. What I need to do, oh yeah, there, it looks like that the reading is down at 0. So I can assume that those two sides are connected together. So the next thing to do was to work it all out and draw out exactly what I'd come up with. To do that then, I looked at the layout of the LEDs on the microbit and drew out a matrix the same. So that what I had was, here is Norton 1, Norton 1 down here, same as this resistor, this one, this LED, sorry, Norton 2, Norton 3, Norton 4. So that I've got the layout of the LEDs here. I then went through and tried to sort out what was connected to what. But I found it very difficult to visualize what was going on this particular circuit. I also found, while I was on with this, that pins 19, 20 and 21 on the microcontroller also came to the LEDs. But very difficult to follow what's actually happening. So I redrew this with the LEDs not in the same location as they are on the board. And what I came up with was the columns and the rows on the edge of the microprocessor, or the microcontroller, sorry. So what I have, I label 19 row 1, 20 row 2 and 21 row 3, just because it was convenient. And then I had each of the resistors on the board coming down as the columns. So column 1, which came from pin 8, I've drawn in yellow. What I should have, of course, is a diode across each of these junctions. But I think you can get the idea that the blue line connects to the yellow, then the blue to the brown through an LED here, LED here, LED here. So I haven't actually drawn them in, but those represent the LEDs. How does it work then? Well, this is what's called multiplexing as far as I understand. What happens is row 1 will go high, and then we'll set up the columns. So for example, if row 1 was high and the yellow column was low, then this LED would light. All these LEDs aren't going to light because these two rows are low. So we could light up any number of LEDs on this row, then switch that row off and switch on the next row. Light up any of these LEDs depending upon how we set up the columns, and then move on to this row, making this high and those two low again. So nothing will light up on these, but any of the columns that are low will cause these LEDs to light up. Okay then, so can we actually see what's going on this? Can we measure it on an oscilloscope or something? So let's have a go. If we get the microbit, pop it on to here so we can see it, then turn it over to get to the processor again, and get our leads for our scope. Now the microbit on the bottom has got connectors that enable us to get the output, to get the voltage, and 3 of the outputs very easily. So what I need to do is to connect to the ground connection first of all. So if we look at this, the ground connection is over at this side. Can't say I'm happy about this, but it seems to work alright, and most people don't seem to have a problem with it. So there, we switched it on, we've got power, and what I'm going to do then, I'll look at the LED side, I suppose is the easiest. If I look at the LED side, what I can do is to just touch the pin against the bottom of the LED to get a trace on the scope. So what we need to do then is to have a look at the scope. So if I put the camera up near the scope, hopefully I can get a picture. There we have a picture of the scope. I've got it on dual channel so that one input is going to be the top line and the other the bottom line. So let's try first of all with the bottom line. Try touching the bottom of one of the LEDs, and there we get a signal trace. If I can hold it on properly, find it somewhere there. Hopefully you can see we've got a trace, or I can get a trace occasionally. Can't get onto that one. Let's try a different one. There you can see I've got a trace on one of the signals. You can see that it's high. You can't really measure it there, but I think it's on about 0.5 millisecond pulse. So it seems that the input is high for 5 milliseconds and then low for 10. Okay, if I try now to use the other probe, I need to find a different signal, hopefully. So let's try. Can get that onto one signal and that onto the other signal, and hopefully you can see that when one's on, the other's off, and that there's a gap when neither of them's on. I assume that that's when the third line, the third row, goes high. But with the dual scope, I can only show you two traces. So we can see that these are being multiplexed. We can see that the rows are going high and low. And that in fact the LEDs are being multiplexed. So let's have a look then at another diagram that will show us easier how the rows are actually connected together. Just switch that off, get rid. What I can do then is look at this diagram where what I've done is to put the processor up here at the top and then show each of the pins where they're connected. I've got row 8 down at the column 1, which is to pin 8, column 2 to pin 9, column 3 to pin 10, etc. With 12 and 13 I haven't used because they're the power connectors. 14 column 5, 15 column 6, 16 column 7, 17 column 8 and 18 column 9. And then I've got my 3 rows up at the top. So what we've got then is these lines, as we saw on the scope, going high for 5 milliseconds and then low for 10 milliseconds, while the other two go high and then come back again. So what have I learnt from all this? Well, I've learnt that yes, there are 3 rows and 9 columns, which would give me 27 LEDs, but I assume they only want 25 and therefore haven't included these 2 LEDs. Also, they've brought out 6 of the columns, 6 of the 9 columns they've brought out, so 3 of the columns they haven't actually brought out. So this I've found absolutely fascinating project. I hope you have too, and I hope you've enjoyed watching. If you have, thank you very much. Bye.